our next speaker. Chad Antle, PE, is Chief Executive Officer for BioWorks Energy. BioWorks, a Michigan-based firm specializing in the design and operation of biogas production facilities that utilize organic waste. Chad has developed detailed hands-on knowledge of both design and operations of anaerobic digestion systems in multiple markets, including agricultural, industrial, and municipal. Chad has over 23 years of civil engineering and management experience, including involvement in capital projects, research, and plant operations. Chad earned both his Bachelor and Master's degrees in civil engineering from Ohio University. His primary focus has been in solid waste and wastewater engineering and operations. Industries served during his career have included alternative energy, wastewater, solid waste, and land development. He routinely provides wastewater and anaerobic digestion process training to the members of the Michigan Water Environment Association and third-party groups. BioWorks supplies local solutions to global issues by designing, establishing, and operating biogas production facilities. The biogas produced by BioWorks can be used as vehicle fuel, power production, or heating. Biogas is a valuable and environmentally friendly energy source produced from local substrates and waste. And I'm going to go ahead and stop screen sharing now so that we can turn it over to Chad.
Good morning. Thank you for having me here. And I should add that when Jennifer says Ohio University, please note that there is no "the" in front of that because it's not Ohio State. It is Ohio University Bobcats. So just for all you non-Ohio State people out there, hopefully a bunch of smiles. So BioWorks Energy, as Jennifer said, is focused on anaerobic digestion as an offering. We've got quite a bit of, start my video. Sorry, Jennifer. There. So we've got quite a bit of experience designing, building, and operating digester systems on all different fronts. We actually own and operate a large anaerobic digestion system in Flint, Michigan, where we take in a lot of different materials, substrates, and whatnot or feedstocks from wastewater sludge, treatment plant sludges, and food processing waste from food processors, as well as grocery stores and food events and whatnot. So you can see below that we've got quite the experience in terms of different types of facilities, and we're happy to bring those to our clients and help them have successful projects. Again, some of the things that we provide, I won't focus on this too much because we want to get into co-digestion. I know earlier we talked about digestion, just a quick review. So we have organic materials that go into a reactor that's around 100 degrees in temperature, Fahrenheit that is. And the byproduct of that digestion of the material within that reactor can be used for several different offtakes, biomethane or RNG, combined heat and power as electricity, and then of course the very valuable nutrient-rich fertilizer value of the digestate. So what's co-digestion? Co-digestion is really brought about by the idea of most digesters are designed to digest one item, and that could be manure, that could be a wastewater sludge, that could be a food processing waste. And in most cases, those digesters have been designed with some goals, some regulations that actually probably allow them to be overbuilt and provide some excess capacity. So the idea is that you can take that excess capacity and actually utilize it to a higher level. So you can lever it and bring in other organics, such as you see in these pictures, maybe vegetables, it could be post-consumer food waste, pre-consumer food waste, and look at that material and say, okay, can we make energy out of that? And the simple answer is absolutely. Why co-digest? In most cases, from an owner's perspective, you're going to look at it and say, I can increase my biogas production. So the benefit of also that you get out of that is you're going to increase the volume of digestate and potentially the nutrient value of that digestate. Certainly the organic value is going to go up. The nutrient and really the nitrogen and the phosphorus value will likely go up as well. And there's going to be a benefit to land application programs or nutrient recovery programs. With increased biogas production, you also will have increased revenues. And that revenue is either in the form of electricity or, as we've spoken so much about today, RNG. But revenues can also be in regards to the tipping fees or the receiving fees for taking that, or that organic waste into the project. If we're talking about a simple dairy digester system, the farmer, the dairyman is taking in his manures into that digester as a way to manage the manure. Managing the manure means reducing odors, be able to carve off energy, but in this case, he's really not getting paid for it. It may be a cost savings internally to the farm, but it's not a true revenue source. Bringing in other feedstocks, substrates, as we call them, can generate tipping fees, and they can actually generate considerable tipping fees, sometimes outweighing more than the electrical production, typically not outweighing the RNG revenue that is being seen today. But obviously that could change. And lastly, help sustainability goals. It may be internal to the farm, to the dairy, or it could be helping out those companies that you're working with, taking those materials, meet their sustainability goals. And we're seeing this happen more and more today. And I think it was mentioned by the fellow with Eco Engineers that there's a drive for kind of this volunteer market of sustainability that's seeking renewable natural gas. Well, we're also seeing the same thing, that companies, mainly food processors, such as a Kraft or a General Mills, the soda manufacturers, Pepsi, Coca-Cola, are really looking at trying to become more green. In the past, this was quite a bit of talk without a lot of value added to it. Today, we're seeing the dollars and cents actually come into that. And so companies are interested in getting their materials out of the landfill, and therefore they're willing to pay for it. Which is a great thing. So some facts about co-digestion. When you look at kind of the general idea of what this really means, I'm going to have you focus on this table, and you can look at sludges, and really we can put that in as manures versus generic food. Fog is considered as fats, oils, and greases, and then dairy processing would be something like coming out of a milk processing facility, not manures. You can see the relative concentration in terms of total solids and volatile solids, and then you can see tipping fees by the gallon or by the ton, and then by the load. And at the very end of the table, the very right of the table, is the relative gas production that you get out of those. So the thought process is, if I can get paid for the material coming into the system, and I can produce more gas, which means more revenue on the offtake, electrical or RNG side of things, it's really a win-win situation. And the question really becomes, can your facility handle it? Handling it is in a lot of different terms in regards to physically, from a management perspective, from an overall process perspective. So those are some things that we'll talk about as we move on in the presentation. So what can you co-digest? A lot of feedstocks, people look at it and say, well, I'm not sure if I can do that or not. Some are really easy to digest, some are really hard to digest. And what does easy and hard mean? It really means, is the system set up for it in terms of the intake of the material, the detention time, or the ability for the digester, the reactor, to do its job, and then the ability to manage the digestate and the biology coming out of the system. So this provides you a kind of a summary of lists of, or a summary of items that are typically co-digested with wastewater sludges, manures, such as cow, pig, poultry, etc. As you can see from the list. And again, some are great, some are more difficult to manage. Glycerol is one of those that you put it in the digester and you get a ton of gas, but a lot of people will say it's kind of like giving a digester crack cocaine. It's great at first, and then things really start happening in a bad way. So what we're going to look at now is kind of the difference between animal manures and external substrates or feedstocks. And you can see through these tables that there is a difference between what you get out of them. So the benefit of strictly digesting manures is that it's a well-balanced diet. Typically when animals are fed, the dairyman, the farmer wants to make sure that the animals have all the right nutrients to produce the most milk, to get the greatest weight for slaughtering, whatever it may be, but they're feeding them a well-balanced diet. And that well-balanced diet is well known to the farmer because obviously it's the bottom line that he creates by having healthy animals and animals that are meeting their quote-unquote performa or expectations in production. Gas production is not bad, usually 55 to 65% methane, pretty easy to mix. But part of the problem is with manures is that it's already been through a digestion process. Therefore, a lot of energy has been carved out of that manure and used for the metabolism of the animal. So we're kind of digesting what's left over. We look at food waste, and now we're talking about really something that's completely different. Typically, again, it hasn't been digested. It's something that's coming off of a production line that has been a mistake or just the waste generated in the overall process, but a lot more volatile solids, potentially higher methane potential, a lot different energy densities. And I'm sorry, I've got in this slide, it says higher energy densities than WWTP sludges. That really could say and should say manures as well. So I apologize for that. But again, these materials have not been through the stomach of an animal or a person, and that energy has not been carved out of them. So we have it readily available for the digester to convert from the organics to the biogas or to the methane. One of the major problems with food processing waste, unlike the manures, is the fact that a lot of times these materials will not have the macro and micronutrients that the digester needs for long-term performance. Often when we're teaching classes to operators or engineers or potential groups that are looking at digester technology, we'll ask them, how would it feel to be on a diet of Coca-Cola and maybe McDonald's French fries for a month? The first week, maybe the first couple of days, it's gonna feel pretty decent for some. Getting into week 2, 3, 4, most people are saying, no, I'm good. I want to go back to my well-balanced diet. And the same idea here is if we start feeding the digester a single material that isn't well balanced, or if we unbalance the digester by feeding a lot of one material, even though we may have some manures or wastewater treatment plant sludges that provide some of those macro and micronutrients, we could see a depletion of those quote-unquote vitamins that the digester and the archaea or the microorganisms within the reactor actually need to be successful in their process. Obviously, if they're not successful in their process, then that means we don't get any biogas. And then the question is do you come back and say, well, maybe I really shouldn't take that in. So you can see where the planning of how and what you're going to take in is going to be really critical for success. Again, proper combination of both better than either component. And we do see, I should make a note that we do see that when you co-digest, that you get overall better digestion or greater digestion than you would with just a manure. So there's some synergistic effects, and really a lot of that is caused by kind of having a better microorganism population in the reactor that can handle more processes or more materials in a different way that allow biogas to be produced at a higher rate. So in graphical form, we can see that a ton of manure is the lowest production of biogas. And then we go to carbohydrates as being going up the ladder, wrong, proteins, another rung up the ladder, and then fats, oils, and greases as being the highest. Again, easy to digest manures allow readily available micronutrients and macronutrients that allow this system to work very well. Carbohydrates, proteins, and fats, depending on the ratio that you're mixing those with, or in total what you have in the reactor, you can start seeing some depletion of those and can be quite problematic. Interestingly enough, food waste from like grocery stores that is a combination of carbohydrates, proteins, and fats typically don't have that depletion effect because, again, it kind of represents that well-balanced diet that we eat on a daily basis. So feedstocks, they can be influenced by a number of characteristics. And what I mean by influence really is, are you going to take them in or not? And this is often not thought about by the typical farm digester when this happens. Typically what happens is a broker will come to the farmer and say, hey, I've got X number of gallons or X number of tons of material. I can pay you for it. I'd like you to take it. And the dollar signs are kind of seen by the farmer. He kind of says, yeah, why not? Let's try it, right? But there's some issues there that if they're not really thought about or evaluated, that could cause problems. The first one is digester capacity. Digesters are designed for a certain hydraulic or liquid loading rate. If we exceed that, we're going to have problems with the digester, and the reactor won't do its main job of handling the manure. And obviously, we don't want that to happen. Biogas handling capacity. So this is all the pipelines and the appurtenances that handle the gas and get it to where it needs to be. And that might be an RNG conditioning system. It might be an engine generator. Ultimately, it could be a waste gas burner or a flare. If those systems, including the pipelines, the safety devices and whatnot, aren't able to handle the additional biogas capacity, it could have detrimental effects on the structural components of the system, i.e., we could have damage to the digester tank or the digester lid because of overpressure, the potential for emitting gas to the atmosphere. Biogas, obviously, roughly 60 to 65% methane, so we can have a very environmental hazardous gas, greenhouse gas going to the atmosphere, and we want to minimize that. But if you're overproducing gas, which sounds great from a monetary standpoint of electrical gas production or RNG production, but we're letting that gas go to the atmosphere because we don't have enough capacity in those facilities, then we're really doing more harm environmentally. Regulatory, that could also be an issue depending on your state. Air permitting agencies could identify that and go, wait a minute, why are you having this much gas go to the flare? Even worse, if the flare can't handle the capacity, it could be simply vented to the atmosphere. Obviously, a no-no from an environmental standpoint, but also could create a hazardous event and we certainly don't want any explosions or spark ignited events going back into the system, because we could have major problems at that point. Current disposal costs. So what is the alternative for this waste, and where is it going now for disposal? Landfill, compost, animal feed are all different opportunities that exist today. So is there another facility that's close? Is there another digester that's taking it that it's close? And you have to look at that and say, all right, is it worthwhile for me to take this stuff in from a monetary standpoint to cover all my costs, and really going to be competing against the alternative or the current disposal costs for the facility? One of the things that we've seen quite a bit is the lack of digestate storage. Farmers will, again, like the dollars on the front end. They'll see the gas production increase. And all of a sudden they go, wait a minute, it's a wet year. My lagoons are getting full because I'm taking in an extra 10, 20, 30,000 gallons a day of liquid waste. And although the digester reduces the waste volume in terms of the solids going to gas, it really doesn't reduce the liquid volume. So if we have 10,000 gallons of let's say milk processing waste coming into the digester, or we're going to have 10,000 additional gallons of digestate going out to storage. And that can be problematic in a number of ways. One is just the sheer volume and storage requirements. The other could be nutrient loading to the land, most importantly, nitrogen, and in the Great Lakes area, most importantly, phosphorus. That hits home to us quite a bit because we live in Michigan. And then regulations. Sometimes states, if you're on a CAFO or under a general permit at a farm, some states will only prevent you from bringing in too much material, limiting it to 10, 20% of your overall manure production. So all things to be thinking about when you're looking at those different substrates or feedstocks coming into the facility. One of the big things that we see is, are you really getting what you think you're getting? A lot of times, again, we'll have brokers come to us, vendors come to us and say, hey, can you take our waste? And they'll offer that shiny penny in front of you to take it, or shiny pennies in front of you to take it. And sometimes those dollars and cents can really be attractive, and you tend to gloss over some of the more important issues. So one of the things that we encourage is that you really need to understand the source of the feedstock. And that's not just asking whoever's bringing it to you as a vendor, but really going to the source. So that is going to the production facility, getting in contact with their environmental health and safety manager, their plant engineer, their waste coordinator, whoever it may be, and asking questions about how the waste is produced. You really want to dig into this. You want to know what potentials are in the waste that could cause problems in the reactor or the digester. We need to understand how the feedstock is generated as part of that. Does it have a lot of debris in it? Does it have contaminants in it? Does it have clean in place chemicals from wash down operations at the facility? We need to understand that so we can protect the main business of digesting that manure on a daily basis, and not just taking in something that eventually we see a problem with. I should make a note that a lot of times when the digestion process is taking in substrates, at first blush, the gas production, the opportunity for the reactor to really work well seems to be on a good pace, but be on a good track. And it takes time for that reactor to sometimes adjust, and unfortunately adjust in a negative way. And I'll use the term crash based on too much of one thing or something in the feedstock that can cause problems. So these two comments about understanding the source of the feedstock, understanding how it's generated, then obviously leads to the risk assessment. Are the gains of bringing this material into your facility worth as compared to the potential revenue streams. And that's something that's got to be evaluated on a case-by-case basis. One of the, I think, is one of the underlooked items in a lot of co-digestion facilities is record keeping. So we need to understand what's coming into the plant. How do we do that? Well, we need to track bills of lading, these BOLs for the trucks coming in, obviously invoices. And then really importantly is the mass balance. Do we really understand how much we're loading to the digester on a daily basis? Do we understand what the impact of the loads are? Are we keeping the right records? This is where a lot of times, because manure is so easy to digest and it's fairly consistent coming out of, might be the end of the sand lane or, however the manure is getting over to the digester. It's a pretty steady process, and there's not a whole lot of question marks of what's going into the reactor. The number of cows in the herd stays the same, so the manure generated is fairly consistent depending on weather and feed and whatnot. So bringing in other materials, well, that can really change things. And who's keeping track of that? Who understands the mass balance, the chemical, the biochemistry that's going on? Who's doing the testing to make sure the reactor's in good step and is staying healthy? That takes a lot of work, and sometimes that's undervalued and not accounted for in the cost of doing business. According to that, how much is too much? Can you handle it? This is something where, again, if you start going down the road of one substrate, a lot of that single substrate with manure, you can actually overload the reactor. A good example of this is fats, oils, and greases, or grease trap waste, brown grease, whatever it may be. A lot of times it's very hard to get rid of, and people are looking for outlets for it, but you can get overwhelmed with it. The fat and what we call the fatty acids within the fats, oils, and grease can build up in the reactor, and that can cause a real issue down the road. When I say that, a real issue down the road, what I mean is digester failure. Digester fails, what are you going to do with your manure? What are you going to do with your commitment for taking in this material, so forth and so on? So something to really think about. Again, it goes back to the management of taking in those wastes. So when we look at evaluating a system and saying, can this digester take in more? We're going to look at first the digester and look at the hydraulic retention time. How long are we allowing the microorganisms and the waste or the manure, the food, however you want to term that, stay in the reactor? It's got to stay in the reactor, between 12 and 20 days, typically, depending on the process and the style of the reactor. We're also concerned about the organics that are in the reactor. So we can overload the reactor with too much food, kind of like eating too much at a Thanksgiving dinner. And in our case, falling asleep watching the Lions lose again. Mixing equipment can be a challenge as well. The mixing equipment is designed specifically for one type of feedstock and the thickness and the viscosity of that feedstock. And now we start adding in other items that cause that thickness or viscosity to increase. We may not have enough energy, horsepower within that mixing system to keep the system mixed. And what does that yield? One, it's going to yield less biogas, and potentially it's going to yield a lot of material sitting on the bottom of the digester that eventually somebody's going to have to clean out. Biogas capacity, again, we've got to look at, can we handle the additional gas that we're going to produce? Is it really worthwhile taking in this additional gas, or substrates to create the additional gas if we don't have a use for it? Sometimes the answer might be yes, if the fee, the tipping fee for the material is good enough. But then you have to ask yourself, can I have that additional gas in the system? Do I have the capacity to handle it from multiple perspectives? Again, we talked about pipeline capacity of the liquid, of the gas, but also we got to get the feedstocks in and out of the reactor. So we have to have big enough pumps to to feed and waste out of the reactor. We've got to worry about the safety equipment being sized appropriately. If it's not, and we do have an issue, you could see a digester implode. So that means sucked in, or explode from a standpoint of just too much pressure on the tank more than it was designed for. And then obviously, again, can we actually make use of that gas? Do we have an RNG plant or a CHP plant that has excess capacity? Obviously, the regulatory environment is critical here too. Digestate, do we have the land application availability? Do we have the number of acres that we need for the nutrients, for the agronomic rate? Do we have the size of lagoons that we need? Do we have the processing equipment that we have? Or is the processing equipment available for us to handle that digestate? Do we have the manpower to handle that digestate? All critical questions that have to be answered before we start taking in this material. Regulation wise, again, we're going to look at our permit if we have one and ask ourselves, am I allowed to bring this material in? Am I going to be able to meet my core requirements in that permit, whether it's a discharge permit, whether it's a land application permit? If I don't, then what do I need to do to allow that material to come back in? Going back to the permitting agencies is not always fun. A lot of times permitting agencies will not necessarily understand the co-digestion process, even though that's changing in a great direction. So there's a lot of education has to go on there. Industrial, in most cases, you have to look and say the industrial facility, what is their main goal? It's probably not creating biogas. It's probably making the product that they are making. If I'm a baker, I'm not necessarily interested in making biogas. I'm interested in selling bread. A lot of times we see the same thing with farmers. I'm not interested in making biogas or bringing in other materials for digestion. I'm interested in making sure the crops are planted, the crops are harvested, and the cows are milked. I think we've heard from others today that the financial incentives are changing changing those attitudes, which we think is a good thing. And then, of course, what's the local regulations require? Do I have limits on road restrictions in terms of weights and truck sizes coming in? Do I have neighbors that don't like the trucks coming down the road more than normal? And then what do I have to worry about from a zoning perspective? Jennifer, I should stop real quick and ask you if we have any questions that we need to answer.
I think we got one in the chat. How would co-digestion of food waste affect RIN classification?
That's a great question. And I don't have the perfect or the highest educated answer to that. But what I do know is that manures, in most cases, in wastewater treatment plant sludges meet D3 RINs, and D3 RINs have a higher value than what most food processing waste have, as they're classified as D5s. We're not experts on RINs. I know that the guys at Eco Engineers, through our conversations with them and obviously listening to presentations like this, have much better understanding of how those are can be affected by what you're taking in. I have heard that food waste that would normally go to a landfill would be destined for a D3 RIN, but that's more hearsay, and I can't verify that in totality.
Great, thanks. I think that's all the questions we have at the moment.
Okay, good. So the balance, right? So the balance is digesting too much of one feedstock. Again, we need a well-balanced diet. I can't underscore how critical this is. This may not be something that you see right away. If you have an unbalanced diet, it could take a month, it could take 2 months, it could take less than that time as well. But you could be going into this process and saying, hey, I really like this. And that's really what I mean by feedstocks that may seem good at first, really aren't. And again, it goes back to the combination of what feedstocks am I taking in? Am I taking in too much proteins? Am I taking in too much carbohydrates? Am I taking too much fat? Again, think about your own stomach, well-balanced diet. The impacts to disposal options. If I'm heavy in nitrogen, I eat proteins, or heavy in phosphorus, or whatever the materials coming from, like soda, or they have phosphoric acid in the soda pop or the cola. That materials end up in the digestive. And now that's going to change your agronomic rate of application because of the nitrogen and phosphorus. Obviously, there's ways to pull that out of the digestate, but it's something that, again, you have to consider. You don't want to be backed into the situation and say, whoa, I've got way too much nitrogen. Where did this all come from? Or way too much phosphorus. The other thing is contaminants. A lot of times we will see that depending on how the waste is segregated or disposed of at the processing facility, is that it becomes an easy spot for the employee walking by that just finished up his lunch or Coca-Cola or whatever it may be, to throw that Wendy's bag or that pop can or bottle into a roll-off that has all the food waste that's destined to your facility. And now you've got to deal with that. Something to be very concerned about. That means plugged pumps, that means plugged up systems, and then ultimately, if that material gets out into the digestate or out with the digestate, it could potentially either settle in the lagoon or get land applied. Some people just see that and say, wait a minute, I got trash versus a nice organic product that's benefiting the soil. So is it worth it? I look at this very simply as kind of the pros and the cons. And I'm going to tell you this, we are a huge proponent of co-digestion. So I don't want you to take any of these slides as being negative or something that says, oh, don't do co-digestion. And how do we establish the tipping fees? Well, how bad do you want this material? So if I have an RNG facility and I'm taking in materials, or if I have a CHP facility, combined heat and power facility, and I'm taking in materials, and I get paid a lot of money for that material, that electricity or that gas, then it can make taking in substrates or feedstocks very worthwhile. All depends on the market. What will the market bear? That's on the back side in terms of power production. It's on the front side in terms of alternative disposal markets. What's the landfill tipping fee? Is there a digester that's nearby that's charging X pennies per set or per gallon? That's your competitor. Is there a compost facility? Is there a solidification facility? Who are you competing against? Don't just take a number and say, yeah, 5 cents or 6 cents is good, or 3 cents is good. Really evaluate what the market can bear. Where are you making your profits? On the front end or on the back end? Again, how do you balance out the overall revenue streams that are coming into your system to drive the ultimate goal of gas production? Now, on the expenses side, in order to take in these materials, obviously we need additional manpower, or we need to have a person that can do that record keeping, that can do the accounting, that can do the mass balance, that can do the chemistry to make sure that the digester is operating correctly. That obviously all has a cost to it. If we're sending more through the system, we're going to have more consumable costs, such as electricity. We've got higher pumping rates. We may have to mix more, have to land and apply more, right? So we've got more diesel being used to get that digestate onto the fields. Chemical demand could be another issue. If I have a high protein substrate that's coming in and it's creating a lot of hydrogen sulfide, and that's detrimental to an engine generator or an RNG upgrading facility, how do I deal with that? You may say, well, I'm going to add some some metal salts to try to precipitate out those sulfides. Again, additional cost that has to be brought into the tipping fee. Additional disposal and reuse volumes are obviously can be something that takes a lot of time for the farmer to deal with on an annual or a periodic basis when he is line applying this material. But does it outweigh the cost of fertilizer, or the decrease the cost of fertilizer because it's acting as a fertilizer replacement? All things that you really have to look at from an economics to say, okay, is this really worth it? And when you go through this process, then you can really determine what your tipping fee is. Don't just take a tipping fee because it sounds good. And we see this a lot. We see farmers that will say, hey, this guy's giving me 2-3 cents a gallon, 4 cents a gallon, and it's undervalued. And therefore, he likes the dollars on the front end, but really hasn't done the analysis on the back end to see what he should be charging. Now, tipping fees and materials coming into the digester is not something most farmers are designed, if you will, to do, right? So what we see brokers provide this service. So there's vendors, brokers, however you want to call them, that will go out and say, hey, wait a minute, I know where this waste is, and they're trying to get rid of it. I'm going to find a home for it, and they're going to bring it to your facility, your digester. What we've seen is that brokers will commonly push down the available revenue to the digester facility, almost saying to the farmer, well, this is what I can get you for it, and that's about it. And the farmer kind of says, well, I guess it's better than nothing. Well, that's not fair. The broker does do a lot of work. He does have good relationships, or can have good relationships with the waste generators. But really, the digester and the digester system is doing all the heavy lifting. And you need to make sure that you get paid for that heavy lifting. How does that really happen? Again, know your market. You know, if he comes to you or she comes to you and says, hey, it's 2 cents a gallon, and it's actually going to a landfill at 25 cents a gallon, you kind of know you're being duped. So at that point, knowing your market is so critical. Take out the middleman. If you have the time to do that, that's great. More importantly, don't let that broker ruin the relationship with the waste generator. Ultimately, the waste generator needs you, you need them. Don't allow that middleman to kind of wreck that relationship. That's really the key part of doing business. This is kind of a buyer beware, right? They're willing to tell you what they want you to hear. A lot of that goes back to the dollars and the cents. It also goes back to the substrate characteristics. Typically, you're going to ask the broker, well, give me some testing, show me some data on this material, so forth and so on. And you'll hear, well, I tried to get it, I can't get it. They don't have any of that. Well, that's not an excuse to say, okay, I guess I'll continue to take it. No, you need to do your homework and make sure that it just doesn't come into your facility without really knowing the details, as we had talked about earlier. Now, I may seem, again, a little bit down on brokers, but you just got to find the right guy. You got to find the right person that can do this work and sees the relationship between the digester and the broker group as a long-term ongoing relationship. Now, the other alternative is, of course, you can do it yourself, but that takes time, energy, and money. So you can either allow them to do that and pay them a good value for that, but not get compromised in what you should be taking, or again, do it yourself. Again, planning and evaluation is critical. Think about the unintended consequences. Think about long-term plans for filling the gaps when that feedstock disappears because of another competitor. And ultimately, who manages this? thank you so much for having me. I really appreciate the opportunity to speak. And sorry that we ran a little bit short on time. Happy to answer any questions.